Okay, Karal, I think you can start.
Sure, thank you. Let's give it another few seconds and we'll start. I'll wait for my computer to say 10 o'clock, 11 o'clock, sorry. Good morning, everybody. It's 11 o'clock and I think we can start with this webinar. Welcome one and all. This is a webinar entitled MMB in Action. And you'll surely see that it is MMB in action. In MMB, we have a saying that says, ignore MMB at your peril. And if you think about financiers and funders who fund energy management and energy efficiency projects, they want to be sure that they get value for the investments and that the intended objectives of the funding have been achieved. MMB provides this assurance that this has happened. The future of the ESCO industry and energy management in management projects will, even in South Africa, will be in energy performance contracting. And you will realize that MMB will become a critical role in that space. Because without MMB, you cannot perform MMB or report results on how the contractor has performed. I am Carl Steyn, the Measurement and Verification Communities of South Africa's chairperson, and I will be the facilitator for this event today. Again, welcome to this webinar. We trust you will find the value and get some questions that you might have addressed. And as you can see from the videos, we have very capable individuals who will share information of interest with us today. And I'd like to introduce each one at a time, with them then providing us with an introductory comment to start off with. Let's start with the presentations will follow the same approach, the same sequence, but let's start off with Peter de Villiers then. Peter, opening comment, please.
Thanks, Carl, and thanks everyone for being here. I think it's quite valuable if we all share information. My opening comments basically that we can see lately, the energy landscape is changing. Companies are under pressure to reduce their carbon emissions. We're also looking at net zero targets. Some multinationals are driving that quite hard. And then there's obviously energy security that's become a problem in South Africa, a big challenge. And getting to net zero or trying to alleviate yourself from the energy grid or electrical grid is quite expensive. And I was thinking I will today talk about, since it's such an expensive process, there are some green grants and tax incentives that companies can rely on to, lessen the cost of going green and, getting energy security. So I'll talk a little bit more about that later.
Thank you, Peter. Thank you very much for presenting and joining us today. Christo from Merwe, I'll introduce them in more detail later on before they present, but this is just opening remarks. Christo, opening remark from you.
Thank you, Carl. Team, morning, everyone. Yes, basically hooking on to Peter's comment of the changing world of energy and so forth, the whole CMPP program has changed as well. The fundamentals are still the same, so don't worry about that. We haven't introduced any Martian clips or something like that. But I'll be telling you a bit more about the new CMPP training program, what we entailed, and why we've done the changes that we did. And of course, how does it affect the current CMPPs?
Thank you, Christo. And then Dr. Marcus Storro. Marcus.
Hi, thank you very much, Carl. Yes, welcome everybody. I think this is a splendid environment to learn more. I'll be presenting some historical facts to a sense. It's mostly part of my PhD, which was submitted in 2018. But I think there's much to learn from that in the current environment, and hopefully I can contribute to somebody struggling somewhere and make some M&V projects viable, which was too difficult in the past. Thank you.
Thank you, Marcus. And then Dr. Mark Rollins. Mark, if you can
thank you,
provide
Carl.
us with the opening, please.
Okay. Thank you, Carl, and thank you for the opportunity to share some of the stuff that we're busy with. Our current experience over many years of working in M&V is there's still a lot of misunderstanding about what M&V is and the value that it provides, and with very large corporations. And I'd like to take the opportunity today to talk through some of those things with real examples. And also, one thing that we really are active in is not only 12L M&V, but M&V for a whole range of things, technology verifications, contract management, all kinds of things where M&V gets involved with. And I'd like to talk about a few of those things. And also the matching of engineering and subject matter expertise with M&V and using first principles in M&V turns out to be quite important. And I'd like to explain some of those aspects.
Thank you, Mark. And thank you, gentlemen, for your opening comments. Before we move to the presentations, let me provide some information on how we will deal with the webinar, the rest of the webinar. First of all, the presentations will be made available. Mutlachu will do that for us. Just indicate to him and he'll provide you with a link afterwards where you can get the presentations from. We'll also not deal with questions during the presentations. Please pose your questions within the Zoom chat facility. We will then deal with all the questions during a panel discussion after the presentations. So we will go through the presentations one at a time. I'll introduce the presenters again and the topics, and they will present. We'll do all 4 of them, and then we will have a panel discussions and deal with the questions thereafter. That's it then for the arrangements of the webinar today. The first presenter that I'd like to introduce is Peter de Villiers. And Peter, can you see my slide? That's it.
Yes.
Peter de Villiers, you will be covering the topic green grants and incentives, as you mentioned. Peter is a mechanical engineer and a certified energy manager, energy auditor, measurement and verification professional, and a carbon reduction manager. And he's got extensive experience and knowledge in this field, as you can see in the rest of his bio. Peter, you've got the floor. You're welcome to share your screen as well.
Thank you, Carl. Just kidding.
I can see your screen. Thank you, Peter.
Right, perfect. Thanks, Carl, yeah, for the introduction. Yeah, so I'm going to take a kind of a step back, so I'm not going to focus on too much technical details regarding measurement verification. However, some of the work that we do within the green grants and tax incentive space involves, work being done by measurement verification professionals. And today I will share, some of those incentives and grants just to basically show, that it's not all doom and gloom, getting on this energy security or net zero or, those kind of journeys where we look at reducing, energy consumption and emissions. Yeah, so maybe just first of all, this is our team. So we now call the EY COVA team. Previously we were COVA Advisory, And since 1 December last year, EY has acquired 100% of the shareholding in Cova. So we've joined forces with EY. They also have a very strong climate change and sustainability team, and as well as a consulting team. So within our team, we have about 5 certified carbon reduction managers. We have about 5 certified measurement verification professionals, 4 CEMs, also 2 certified energy auditors, and 3 of us are accredited to issue performance certificates, as well as sign off on energy efficiency savings under Section 12L tax incentive. So maybe just to give you a holistic view, so typically on this strategy to net zero or energy security, there are a few steps that companies will typically follow, and within that strategy, measurement verifications play quite a significant role. With your strategy, you have to set your baseline, to know where you are. You set your goal, what you want to achieve, and by when. And then there's obviously space for energy efficiency. That's always what they call the first source of energy, is energy efficiency. That's where the ESCOs in South Africa will play a big role and are still playing a big role. And then obviously there's step 3, which is sourcing of alternative energies that's lowering carbon, moving from a coal boiler, for instance, to a gas boiler, those kind of projects. And then obviously you can get up to a point where you cannot, get any further. And then there's always the option to make use of offsets, buying carbon credits to reduce your carbon tax liability or get yourself to a net zero status. Now within this strategy, there are some things that drives, the strategy, which is, all the compliance measures, which includes carbon budgets, carbon tax, and there's also a carbon border tax adjustment that is coming soon. That's being implemented by the EU. But then on the other side, you have your incentives. So that's the green bar below at the bottom, and there are some very nice incentives that companies can make use of to just reduce the financial burden on this journey that they are embarking on. So I will now focus on the green stuff. So that's all the the nice stuff. It's typically what I would like to say is the compliance measures are like your veggies. You have to have them, and the incentives, they are like the dessert. That's the nice stuff to have. So the first incentive that's quite significant and assist a lot of companies in being more energy efficient is the Section 12L tax incentive. I think most of us on this webinar is very familiar with Section 12L. I think it's a quite prominent incentive, and that's basically an incentive that aims at promoting investment in energy efficiency projects and implementing energy efficiency equipment. It's an incentive that's started in the end of 2013. Initially, it was at a rate of 45 cents per kilowatt hour that you save, and that is the amount that you can deduct then from your taxable income. Then since March 2015, the rate was increased to 95 cents per kilowatt hour of energy saved. And that actually made quite a significant difference in the uptake of Section 12L. The nice thing about 12L is that you can claim not only for electricity savings, but also for energy efficiency savings on coal, diesel, paraffin, all the other types of fossil fuels. And maybe just to give you an example, high level, energy efficiency project realizing savings of 40 million kilowatt hours will give you a 38 million tax allowance. So if you deduct that from your taxable income, that means your net benefit will be around 10 million. So that's quite significant. Okay, the next incentive is called the Critical Infrastructure Program, CIP. So this is a program that's administered by the Department of Trade, Industry and Competition. And it basically supports the private sector to invest, in critical infrastructure. So that's typically where you have projects that alleviates yourself from the national grid. So typically that could mean alleviating yourself from the electricity grid, or alleviating yourself from the water grid, or even building roads, those kind of things. Those projects will all qualify under critical infrastructure program. So that's a cash grant that you can claim between 10 to 30% of the infrastructures or the capex that you spent on a project, and it's capped at 50 million on the cost that you spend. So the critical infrastructure program recently, well, if I say recently, it was actually last year around May, June, where they've changed some of the wording in the guidelines, and they changed it to clean and green infrastructure projects will also qualify. So this essentially means that solar projects will qualify under this program. We recently also had our first approval on solar projects. So this is a nice incentive, especially for solar projects, since 12L excludes renewables and CIP actually includes renewables. So this is incentive to that's worthwhile taking into account. So just on a high level, so if you qualify, for instance, for 20% grant and you spend 200 million on a, for instance, a 20 megawatt plant, you will receive 40 million in cash. So very important incentive to remember. Then there's also the innovation incentives. I think some of the people on the call might be familiar with it, with these incentives. So there's a Section 11D, which is also a tax allowance that you get. Now typically you can deduct 100% of your cost. With Section 11D, you can deduct 150% of your cost. And that includes, well, typically 11D or R&D cost includes salaries. So if you have an R&D team and you have about 10 people, let's say average R1 million salary per year, then that could be around 10 million that you spend on your R&D. You might also have a laboratory or places where you perform these tests and R&D. All those kind of costs you can include under Section 11D, and then you can essentially deduct the additional 50%. So 150% of the cost you can deduct from your taxable income, and that means it basically equates to a 14% cash benefit. So if you spend 10 million on R&D, you would essentially receive 1.4 million in cash. Then there's also the support program for industrial innovation, which is called SPI in short. And this is also linked to R&D, but this is a little bit further down the line. So 11D starts when you start with your research, and it's very theoretical, testing hypothesis. With the support program, it becomes more real. That's where you start building pilot projects and actually testing your creations. So that's a grant where you can claim 50% of the qualifying cost, and it's capped at 5 million rands. So also a nice incentive to look at. Then of course there's also carbon credits. So I'm not sure how many people on the call are familiar with carbon credits. I think most of us have heard about it before. So a carbon credit is basically a tradable commodity that's created from a project that reduces your carbon emissions. So typically when you reduce your carbon emissions, you can register a carbon credit, and someone else can buy that carbon credit and then to reduce their emissions. So it's basically a paper exercise. So in some instances, especially with some process emissions, the technology is not there yet to reduce emissions. So typically these type of companies, they would like to buy carbon offsets. So these projects must be registered under a accredited standard. So typically CDM is one of those. There's also ECS under Vera and Gold Standard. Those three are basically the main three standards under which you can register your carbon credits. The process is quite a intense process, and you have to also employ verifiers, and they will set up a baseline. They will use a methodology, prescribed methodology, to do the verification, and then you will get your offsets that you can use. So currently in South Africa, within the carbon tax, there are certain allowances, and one of those allowances is the carbon offset allowance. So within South Africa, companies can buy carbon credits to reduce their carbon offset liability. So I'll talk on the next slide. I'll talk a little bit more about how much a carbon credit is worth. So in South Africa, you can register a renewable project for carbon credits, but the additionality hurdles is quite high. So under the Vera standard, you can qualify for a carbon credit project if it's a small scale renewable project. So that's 15 megawatts and less, and it should also be not grid connected. So Vera recently clarified with grid connected, they just mean you should not export into the grid. So then it will qualify as a small scale non-grid connected project, and then the chances are very good that your project will qualify for carbon credits. So if you look at the 15 megawatt solar plant in the example, that would produce about 27,000 megawatt hours, and at the rate of 115 rands per credit, this could be worth about 3.15 million rands per year. And it's also important to note that these credits, you can renew them every 7 years in the case of Vera, and every 5 years in the case of the Gold Standard. So they can have a lifetime of up to 21 years. So it's also a very nice incentive. Then just to talk a little bit about the carbon credit price. So recently, the new carbon tax rate was announced in the budget, and it's going to be 144 rands per ton of CO2. That means it's increasing every year. It's a little bit more than inflation. So, and also what was also announced in the budget speech by the minister was that they intend to increase the carbon tax rate to about $20 at a later point in time, and by 2025 it would be increased to about $30. So that's about 477 rand per ton. So that's quite expensive. And typically, if you register carbon credits, your carbon credits will trade at a discount rate to the carbon tax rate, and that's normally between what we've seen 10 to 20%. So the price of carbon credits is currently at about 150, like I showed in the example, but it could move up to 400 rands in a few years' time. So the carbon credit price we expect to increase over time. Then I'm going to talk a little bit about energy performance certificates. This is not really an incentive. However, we believe that going forward, especially big landlords with offices, they would like to have a good rating that would attract typically more rental income, as people are becoming more aware of being green and the importance of energy efficiency. So I'm sure we'll see in the future, you'll see tenants looking for properties to rent with a very good rating. So there is an incentive in getting your office buildings more energy efficient. So a little bit about energy performance certificates. It was introduced in December 2020. It's a regulation, so companies have to comply, and all companies with a floor space of more than 2,000 square meters needs to comply in the private sector, and in the public sector or government sector, all companies or all buildings with square meters of more than 1,000 should comply with this regulation. So the deadline for EPCs is by the 8th of December 2022. So far, what I've heard from a workshop yesterday, only 47 certificates were issued in the past 18 months. So we expect a big increase in companies looking for EPCs. Excuse me. Sorry about that. So I was thinking of maybe doing a very high level sure, my apologies. So if we look at a very high level example, so this is based on something that we've seen within our clients, and they've implemented 2 projects. So I'm not going to give the real numbers in here because of some NDA restrictions. However, the project involved a heat recovery project. The aim of the project was to reduce the coal consumption within a combustion process. And this company actually did a lot of R&D initially to being able to reduce their coal consumption within their kilns. And yeah, they've got quite a dedicated R&D team, and they spent about 15 million in 1 year in developing this technology. And then they also, I think they have about 12 kilns, and they also constructed a pilot one on one of the kilns, and the cost for that was about 15 million. And the full-scale implementation has not been done yet, but they expect the total cost to be around 70 million. And then they also embarked on a renewable project to alleviate the cells from the grid. So they installed a 10 megawatt plant, and you can estimate the cost to be around 100 million. So the total cost that they had for these 2 projects were around 200 million. And I'll show you now how you can make use of incentives and what the benefit are on these projects. So if we look at the heat recovery project, there's R&D expenses, so you can make use of the 11D incentive. So that's also a tax incentive, and the benefit there in cash would be around 2.1 million. And then if you remember, the other R&D incentive is the SPY program, and that one is capped at 5 million or 50%. So in this case, the lower number is 5 million. So they applied for 5 million allowance or 5 million grant. And then obviously on the expected 12L benefit, they expect to save about 6,000 tons of coal in 12 months. And if you assume a energy CV value of about 25 megajoules per kilogram, just a high level calc, then that would relate to about 11 million of tax benefit that you can get from 12L. And then, of course, with the renewable project, they are applying for CIP, the Critical Infrastructure Program. And if they receive the maximum benefit of 30%, then that would mean they will get a cash benefit of about 30 million. From what we've seen is that most of our clients, they get the maximum benefit of 50%. We normally do our high-level calcs based on 20%, but 30% is not unrealistic. So if you look at that, you spend a total of 200 million, and you can, between all these incentives, you can get almost up to 50 million in cash you can get back in either the form of a cash grant or a tax incentive. So that's why it's, I think, quite important to keep all these incentives in mind whenever you embark on a project where you're about to spend capital or about to reduce emissions or reduce energy efficiency or increase energy efficiency. Yeah, thank you, Carl. That's me. Stop sharing. Over to you, Carl.
Thank you very much, Peter. Very interesting presentation, very valuable information provided, as usual from your team. Always interesting to hear what you're busy with. Thank you very much. The next speaker we have today is Christo van der Merwe. And Christo is he's got a master's in mechanical engineering. He's a certified measurement and verification professional, certified energy manager, and he is the person training all the individuals in Africa with one other, with Dennis van Es. He's also been involved in the development of the new CMVP training course presented by, made available by IPA and AWE. And that's what he'll cover with us today. Christo also has got his own business, CFJM Solutions, and he's also SANAS accredited MMB body. Christo, we're keen to hear from you. Thank you.
Thank you very much, Carl. Thank you, team. Good morning again. Yeah, still morning. How's that? All right.
Christo, I can see your screen.
Thank you, Carl. Right, yes, basically I'm about to address to you the typical actions and so forth that has happened with the development of the new CMVP program, what the changes are, what the effects are on current CMVPs, and what it basically all entails. So first off, just a quick on who we are, what we are. Carl has basically given the gist of the whole thing. We've been in the energy management game since 1999, and we actually have been part of the CMVP training and exams development team for the AEE training program. So the CMVP training program itself has been developed to update according to what's happening in the world currently, and part of those changes are, number one, that, let me just get my pointer going again. Spotlight. How's that? So the AEE and the EVO decided to part ways at around about the end of last year. And in the past, AEE certified the CMVP professional, where the EVO gave training to the materials, gave the training materials according to the IPMVP. As such, AEE, as the official certification body for worldwide energy managers, decided to fine-tune the CMVP training and certification program as well. So we started off in January with a joint task committee with about 15 experts of around the world, and we've developed a new body of knowledge. This body of knowledge, each training and certification program has got its own body of knowledge, which basically entails what the professional needs to know, understand, and work with in order to become certified as a professional in that field. So we applied this towards the MNV, and we all placed more emphasis on the application of MNV fundamentals, not just the theoretical understanding of such, and the real world use of MNV. And I specifically stated here worldwide. This incorporated many things, such as our own 12L tax incentive program, the Dubai development programs that's up there, and so forth and so on. We started in March with developing the new training material once the body of knowledge was sorted. And the first training was given actually about 2 weeks ago in Africa at Kenya. And it was quite fitting, since Africa is seen as the cradle of humankind, that it started in Africa as well. So we're quite proud of that. The second training is actually happening last week and this week in Dubai. And then the third set is happening in Seattle during the week of 13th June. So the body of knowledge itself was developed over a 4-week session with a group of about 15 or so worldwide experts. And it came down, as you can follow on this link, which for the presentations that will be made available afterwards. These are the basic body of knowledges, adjustments, and we've given a large chunk of attention to that, because that is part of the crux of the whole system. And then the two main approaches, and the fundamental side, and on planning. So the top 5 systems are the largest chunk that's being given attention to during training as well as during the exam. And then we follow on with the bottom one, the CMVP, meaning the practical application of MNV and what it entails. Then we also, with the body of knowledge, we also updated the certification criteria. These you can also follow directly from the AEE website. Basically, all of this stayed the same. However, we focused more on involvement of certain persons or whomever into the measurement verification work. In the past, it was stated as exposure, and exposure could be understood and was understood as sitting on the sidelines and just watching the game. But we require involvement, being part of the game, in order to get certified as a CMVP. The new training material itself, we were developed with 6 active MNV experts, with experts in training, expert in application, and expert in development of MNV and other subjects. We were all active in applying MNV and training in MNV. And we had a first with Eric Piller, which is actually a contextual designer. He's a person, we've got a professorate in literature, English literature, and so forth, nothing to do with MNV, but he did an absolute stunning job in converting our language into a training understandable language. So with the whole team, Steve, Chris, Sam, Hassan, and I, Eric was able to actually take our ramblings and convert it into a fantastic training material with new slides, which are focused on giving over knowledge, not just looking pretty and being difficult to present, but actually focusing on transferring the knowledge and the skill from the trainer to the trainees. And part of the system also is then scenarios and participant guides and all that has been developed and are still being improved as we go along, and getting feedback from these initial first 3 training sessions. So the new material had to address the new body of knowledge, of course, as well as the worldwide practical application of MNV, while addressing still the fundamentals of MNV. So for those of you that was exposed to the past training, It was largely focused on IPVP and application on buildings within the US. In this case, we are looking at the IPVP FEMP program, ASHRAE. I think I'm jumping ahead here. So we actually have now the capability to fine-tune the training towards a regional application of MNV, while still being able to show the class that there's a whole world of MNV application out there. What's happening in Dubai, what's happening in Canada, what's happening in India and Australia. Nothing in Antarctica yet, but at some stage that might come into the play. So the first training session happened in Kenya during the week of 10 May. Running alongside of this, as if the first training of the new CMVP wasn't enough, they had a training of trainers program running as well, with these 5 people on the left-hand side being experienced energy managers, and all of them CMVPs as well, being trained for a CMVP training system as well, with the left side 5 persons being the new trainees on the CMVP itself. And they would see some blokes standing in front trying to convey what is happening on MNV. What does the new training involve? Excuse me. We've got 9 modules covering the body of knowledge in a natural flow. We've focused largely on the natural flow of MNV, how it's applied, how it's being used, and how we can address the body of knowledge during that natural flow of application. It's less than 200 slides. The past system had about 80 slides, 90 slides, and 50 slides of 3 modules alone. So we have only 200 slides covering the whole process. May I ask for a mute, please? There's a dog barking at me at some stage, please. Thanks. 2 main examples are being applied that cover the full range and extent of MNV in the application, and they are Excel-based. More examples can be incorporated at the discretion of the trainer, but these 2 main examples cover the whole process. Then we have various scenario discussions per module, scenarios that's been drawn out from practical experience of the developers, myself and the other people, that we present the scenario and how did it came about, and we encourage discussions from the trainees. And that we have at that stage. And it exposes various sources of uncertainty in the whole MNV process. That's one of the major tasks. So not just statistical, but in terms of contractual requirements, metering systems, data applications, how to apply it on modeling, and. So the whole uncertainty process is also much more practically defined and discussed. Right. The results at the end of the day, we got some feedback from the students. The existing CMVP personnel and trainees came back with us stating clearly that the new material is making a lot more sense and has a much better flow towards the old ones, where we had some jumps back and forth, a lot of repetitions, and not being able to understood clearly where this section was fitting in. The new material, current material, flows naturally and enhances the understanding of the process. And the new students basically reiterated that, stating that it felt natural. They were never really lost on where we are now and what's happening on the whole process. A bit on this MVP exam itself. It's a brand new thriller, and it is a thriller. For those of you that have written the MNV exam in the past, remember that it's not the normal kettle of fish. And we've maintained that high level of thrilliness, if you can call it like that. It's 100 questions, 1,000 points, and you still need your 70% to pass, still 4 hours, and it's still centrally marked at the AEE itself. It tests the knowledge based on the new body of knowledge. It tests your practical knowledge, and it tests your understanding. What does this mean to current CMVPs? I was bringing in a slide here that you had to rewrite the exams, but I'm not going to put that on. No. If you have got your certification and everything, all you need to do as a current CMVP is still just keep your certification renewed and ongoing. But just note that recertifications are based on the new body of knowledge, which then requires a bit more practical application on MNV and not just second rate or watching from the stands on how the game is progressing. These are the two links that you can follow on your registration. For local IPA SADC persons, we can follow the IPA certification renewal. For anyone else, of course, you can follow the AEE certification route. For those that did not write the exam yet, you're out of luck. You will need to write the new exam, and that means you might need, and most likely will need, to attend the new training as well. The two are quite different with one another, and therefore it is actually a requirement that you attend the new training as well as write then the new exam. It's not purely based on the knowledge because of the knowledge difference of the old and the new one, but there's some other political and contractual issues as well with the split of AEE and EVO. All right. In summary, the new CMVP is completely an AEE program. There's no other partners, nothing, and they use actual experts from around the world to develop these training systems and all that. The new body of knowledge and training incorporates worldwide application of MNV. The new certification and recertification focuses on being involved in actual MNV. The training can be regionalized while keeping a worldwide approach as well. The training will continuously improve. We already have some feedback from the initial 2 training sessions, and we are incorporating those feedback into the next training sessions, improving the slides, improving the material, improving the process. An additional training on advanced MNV will become available in the near future. Righto. There will be a discussion session afterwards as I have it. So any questions, please, guys, you can field that off during that discussion. Thank you.
Thank you very much, Kirsto. We'll deal with questions afterwards. Thank you for that interesting presentation. The next presenter I'd like to introduce is Dr. Marcus Storm. Marcus is a certified measurement and verification professional with the AEE. He's also a certified carbon reduction manager. He's extremely knowledgeable on metering and anything related to metering. And he did his PhD in thesis in measurement and verification. And his presentation will cover most of that today. As you can see in his bio, there's quite a lot of areas he's very knowledgeable in, both the areas that was covered already and other areas. Marcus, please start with your presentation.
Thank you very much, Carl. Just sharing here. All right. Can everybody see that presentation?
Thank you,
Yes,
we
we
can.
can.
Okay, most one of them. Just going to try to enlarge it. Okay, no, that's not going to work. Let's keep it like just as such. Wait, thank you, everybody. Yes, with the title being of the session being MV in Action, I thought it good to take a part from my PhD study, which will focus on getting a few things done. And that is why also the title of my presentation is Quantified. Presentation content, just a quick introduction and background. Then we're going to focus on project level M&V, and then simply getting savings quantified. Then some final notes and questions. Just again a note, a presentation content is mostly for my PhD thesis with certain parts that was published, and there is just separately, it is just separately referenced. Then quantification of conservation or impacts or savings is widely used across the sectors in each area. And so in each area, the aim and focus of this conversation can cover a variety of aspects. With any resource applied, be it energy, water, being it cooled fluids, heated fluids, or an element in industrial value stream, there is normally both supply side and demand side inefficiencies with optimization potential. Now, as Carl earlier has indicated also, optimization improvements can be costly and stakeholders would like to prefer to see real impacts instead of only rely on technology supplied figures, like there's an indication of this piece of equipment might have this energy efficiency impact on a system. Now, measurement verification principles can be applied on any such optimization intervention project to establish and report on conservation achieved. Now, with that stated, yes, we've in the past, and with this presentation, we'll be diving far in the past with, and I think a few of you guys, and unfortunately, I'm not saying most, I'm not sure how many of the guys that started at the beginning of the DSM era and still involved, but a lot of the parts will be familiar with everybody. With most of you, hopefully. Now, just defining within the PhD thesis paradigm, project level M&V is defined as the full or partial contractual life evaluation of a project making use of full-time or partial metering of key project parameters. Now, your program level M&V is defined as a method of quantification that does not use continuous metering, but incorporates a calibrated simulation model or a deemed savings approach to establish conservation impacts over the program's contractual life. This is such as CDM programs and an old Eskom standard product program. Then lastly, regional level M&V entails a methodology that allows M&V assessments and impact validation at a much higher level, which can be regional, a whole province, or even nationally. Now, we're only going to focus on project level M&V and only also a small part of that. That is only a very small piece of my PhD thesis, and otherwise we're going to stay here the whole day. Getting savings quantified. So we'll start off with the old DSM classic load shifting. Then we're going to move to energy efficiency with an energy governing factor, energy efficiency without the energy governing factor, and within there we've got subtitles of a single pump with constant load. Just as a quick note on the bottom, we are looking for this application from a water pumping point of view. So for any project where there is amount of water or fluids that needs to be moved from one point to another. Yes, then after single pump with a constant load, we'll be checking a pump station with multiple pumps, having different pumping loads with only a single incoming power meter. The reason for choosing this specifically is that with larger pump stations, these has normally a dedicated ESCOM or a municipal power supply point, and there is often metering already existing, so there is a lot of baseline data available, and that is why we're checking this from a point of view of having a single incoming power meter. Then pump stations with multiple pumps having different pumping loads with only a single incoming power meter, and there's operational level variations with boundaries. Now, quickly, load shifting. As I said, this was prominent with many old ESCOM DSM projects, and load shifting only entails moving the load out of the power utility peak usage periods to off-peak periods during the rest of the day or to weekends. Thus, there is no difference in the amount of kilowatt hour used, but only when it is used. Load shifting is specific to daily time of use period reporting. Now, I think few of you might recognize this picture. So with load shifting, on top, we've got the baseline kilowatt demand profile. And then to the right, we've got the actual profile. Now, this is the after implementation. And this project involved switching of evening peak. There was no morning peak switching. So this actual profile. Then we've got the baseline profile energy and also the actual profile energy. Now, these two is supposed to be the same afterwards, with the energy only moved to other periods. From this, a service level adjustment factor can be calculated, and then afterwards for impacts calculation, the baseline can adjust it according to the service level factor. Now, with this implemented, this is just a week profile, and you can see there was specific DSM switching that has occurred, and as the baseline was adjusted accordingly, yes, over a weekend, but probably where there was no switching that occurred. Now, energy efficiency with an energy governing factor. With water pumping, there are many ways to improve efficiency. However, it mainly comes down to reducing the amount of energy required to move the same amount of water. It is important to notice here that less water pump does water conservation, reducing the amount of water for, say, an irrigation crop or for a certain type of crop using less water will, of course, also directly result in energy efficiency. However, in this scenario, an energy meter, but we will not be looking at this. Now, in this scenario, we are fortunate enough to also have, with the energy meter, we also have energy governing factor present, which is the water measurement. So we're very fortunate to have a flow meter installed with this project. Now, for energy efficiency with energy governing factor, reporting may consist of only reporting on the kilowatt hour conservation. Now, this can be typically say for a 12L project, or they can be reporting on the kilowatt hour and also the time of day when the resulting kilowatt demand reduction was also achieved. Now, this is just a quick average demand profiles that was drawn for this project. So in the blue line, we have the average weekday, and then we've got Saturday and Sunday as well. Now, for this project, it was also important just to also consider what the demand was for the different days. But the end, there was only one baseline for a weekday type that was implemented. And we here with a normalized pump energy kilowatt hour against the water pump in liters. And you can see there's a proper relation already between these two variables. Now, this is I think you guys had worked a lot of MNV, getting a a proper scatter plot with a nicely fitting trend line is sometimes a luxury. We were fortunate enough with this project to have it as such. Now, moving, so just to go back, now with this project, the normal, and I don't want to go into much details. So with afterwards, after the project was implemented, this chart will be used to also from the amount of water that was pumped, the kilowatt hour that was used afterwards to move that water will be indicated, and the saving can be calculated. Now, moving to the next part, which I would like to focus more on, is the many amounts and times where you've got energy efficiency, however, without an energy governing factor. Now, unfortunately, with many pumping projects, a flow meter may not be available or could not be installed for the project. And this is in the case where there is a lot of impurities in the water. Then electromagnetic flow meters and such needs to be installed, which is exceptionally expensive. In such a case, some intuitive methods are required for baseline development and service level adjustments to still effectively report on the project energy efficiency impact. The following three scenarios are discussed here: a single pump with a constant load, then a pump station with multiple pumps having different pumping loads with only a single incoming power meter, and then a pump station with multiple pumps having different pumping loads, also, but here with a multi-metering setup. With a single pump and constant load, fortunately, it is quite easy. Of course, we've got no energy governing factor here. There's no water flow data available. With a pumping system, such as a farm irrigation pumping system, there are many scenarios where a single pump motor is operated at a relative constant load. Now, this can be simply just to move water to a dam, or you have a center pivot with a level field, or there's a crop which is irrigated with micro irrigation. Here, the pre and post implementation demand differences as a result of the energy efficiency project intervention needs to be determined. So, for example, in this case, we may have that a VSD, variable speed drive, was installed, and before the project, the farmer's activities was to choke the pump instead of to reach the desired pressure at the last point of water flow, say from the center pivot. And so in the past they were choking, but now a VSD is used, and the speed of the motor determines the amount of pressure at the top. So this normally results in quite a significant efficiency impact. We've seen with a lot of measurements and a big study that was done in around 2013, that a typical impact from a VSD of a farming setup was around 40% a demand reduction, and that is quite significant. One way to measure, then we need to look at for comparing this is to measure a full pre-intervention pumping cycle and repeating this after the intervention. It is critical that the pre and post-implementation cycle measurement must be done with the exact same pumping conditions and preferably in the same cycle length. You'll see just now why this is required. For this example, you'll see we have got the before profiles. This is over a 6-day period. For each day there was different pumping that occurred. However, it's quite a constant load. So we've had measurements beforehand, and we compared it with measurements later. Now, this is very favoring these conditions, since we can compare it hand to hand, and this is not always the case, but for this example, it will suffice. Now here we have got the demand difference, and then the lined area is your kilowatt hour impact and due to the project.
The average demand difference can be established by comparing the pre and post implementation daily demand profile, the magnitude, while the pump is running. From the magnitude of the average difference, and a service level adjustment factor can be determined. For impact calculations after project implementation, the baseline can be inferred by applying the SLA factor to the actual on a daily basis to each 30-minute interval when the pump is running. In this case, it can be done on every single measurement interval, 30-minute. In some cases, your data will be hourly or 5-minutely. Since when the pump is not running, the demand profile will be 0. However, if other non-pumping loads are also captured by the power meter, the adjustment should only be done when the pump is running. Also, the pre and post implementation demand measurement should reflect the same non-pumping load. And here at the bottom, because just a calculation of the service level adjustment factor. Now moving to pump stations with multiple pumps having different pumping loads, but still only a single incoming power meter. When a pump station consists of multiple pumps with different pumping loads, the baseline determination and the SLA method becomes much more complex. There may be a large variety of pumping demand profiles over the measuring period. With typical farm irrigation pump stations, there can be several pumps and many different crop fields irrigated. With this type of irrigation load, the power meter measuring the entire pump station can have many different demand profiles captured. With Eskom irrigation DSM projects, it was often found that only a single main incomer, a time of use power meter, or other utility meter was available. Now again, this is shown within an environment of irrigation pumping scenario, but this may also be the case in any other industrial process. So I think a lot of this can be applicable to industrial processes as well. Keeping this in mind, it is critical that the following requirements are met for proper project impact quantification. The measurement period should show each different pumping scenario for each individual pump in a pump station, with a load profile of a full pump cycle for each pumping scenario. Then also, the measurement period should show each possible combination of pumping operations together with load profiles of full pump cycles for each pump combination scenario. Now, this is very clearly stated, otherwise the approach I'm suggesting will not work at all. So now this is a demand profile over a 7-day period for a week, and you can see here there is different loads that is running, different pumping operations that what we're seeing here captured by the power meter. Now we will be implementing operational levels. Now what I've simply done is this part we have each day was put onto one graph so that we can identify distinct different operational levels. And you'll notice here we've got operation level 1 here, which is there. And then we can see there's another one, which is running around here. And then there's a third, fourth, fifth, and a sixth operation level as well. Now, here we've got the post-implementation demand profiles compared with the pre-implementation. And here you can see that for each of these, we've got the demand impact now. And you will also see the energy efficiency impact. It's for certain operational profile, the parts, it's actually different. So here we've got a much bigger one than this and smaller ones over here. Now, with the demand reduction determined, now that's following this, the exact process of repeating your full demand cycle measurements before and after. We can have a service level adjustment factor can be determined for each different operational level. With the SLA factors established, the same process as followed with the single pump can be used during the assessment period to infer the baseline on each operational level. From here, the baseline and actual profiles can be compared in order to calculate the savings. Now, a pump station with multiple pumps and different pumping loads, and again, only a single power meter. However, we may have operational level variations and boundaries. So what this implies that with the previous one, fortunately we had relatively constant loads. Although there were different loads, each of these were quite constant, but it might happen that there's also variations. And we can see here, with this example, pump station E56, there's quite significant variation compared to a normal constant load. And this happens typically when you've got a center pivot, which is running on a unlevel field, and certain times there's more power required to move the water uphill. Now, what we can do is here to establish certain boundaries with a safety margin. And this can be implemented so that we can find out and just establish which part to apply where. Now, the operational level SLA factor can be determined and then expanded to include the operational level boundary. So what we've done now is for each of these levels, we've established a service level agreement adjustment factor. Now afterwards, with the SLA factors established and the boundaries defined, the post-implementation assessment saving calculations can be done by following these steps. Step 1. The actual profile needs to be analyzed to establish the pumping operational level of the complete assessment period. From the operational level analysis, the correct SLA ratio must be chosen. Then, ensure that the operational level stays within the upper and lower boundary limits. Any outside of the boundary conditions need to be examined. So the moment we start moving outside of the boundary, we need to check what is exactly happening here. Then, from the actual profiles and the SLA ratios, the baseline can be generated by multiplying each 30-minute or hourly 5-minute point with the correct SLA factor. Then, we can compare the baseline and actual demand profiles to calculate savings. Mathematically, the energy efficiency savings achieved for any such irrigation setup may be calculated by applying a formula. Now, I'm referring here, since there's some type of profile here, we can apply a formula instead of trying to establish an average over here. This ensures, if needed, of course, that an average of the variation is not used, but allows that a function can be established, a linear or polynomial, sorry for that, which benefits the operational profile of the operational level. Now, for each operational level, there can be a function established, and from this, we can get a period total energy efficiency impact. The scenario required, okay, just to go back there, so just to discuss the formulas, we've got different pumping events. Then this, of course, we've got a pump start and end times, and then the normal of operational levels here. Now moving to the next part is a pump station with multiple pumps having different pumping loads. However, a multiple metering setup is required. Now, this scenario is required. This requires an approach consisting of multiple meter points and possibly an intelligent meter setup. So instead of relying on operational level conditions and boundary limits, that may be problematic, each pump is separately monitored in this scenario. With this, additional condition sensors can be applied to indicate another pumping condition, which further produces accuracy and data reliability. There are two drawbacks to this approach though. There will be no historical data available with such a specific detail, and then an intelligent multimeter setup can be quite complex and expensive. Then, finalizing my quick run, quantifying energy conservation of pumping, especially for farming irrigation, can be quite daunting. There are other scenarios as well. So this is not the only ones that I've mentioned here. We can also have a combination of load shifting and energy efficiency. Of course, with a site with a flow meter and sites without a flow meter. And then peak load prevention or clipping, only reporting on peak load reduced or reporting on both reduced and energy efficiency. And we've seen with these type of projects, a lot of baseline anomalies, like changing of operational conditions and baselines not fitting the original project scenario. All right, thank you very much.
Thank you, Marcus. As you can see, MMV can be very complex. It can be very simple as well, but certainly it can be very complex. And to note that Marcus is a panelist for 12L, so be careful what you submit for evaluation purposes. The next and last speaker for today, equally impressive qualifications, is Dr. Mark Rollins. And Mark will be covering the sugar mill plant energy savings initiatives, energy impact of dewatering. Mark is the Chairman and Chief Engineer of Energy and Combustion Services. He's a registered professional engineer, certified energy manager, certified measurement and verification professional, and he's the technical signatory for his company, who is also a SANAS accredited body. Mark, please share your presentation with us today.
Okay, thank you, Carl. Let me just see where I've got this. Can you see this?
I can see your presentation, Mark, thank you.
Okay, perfect. But so today I'm going to briefly talk about a project that improved the energy efficiency at a sugar mill. And the reason for this is that there were a number of very interesting aspects to this project that that hopefully will give some insight to other MNV practitioners, and also give some insight into what it takes to do some of these things. Briefly, just go there. Who ECS is? We heavily involved in energy and carbon reduction projects, and especially the digitalization of energy and carbon and the analytics associated with that. So, for example, in carbon tracking and planning, we have huge simulation tools where entire organizations, so whether you're making nickel, iron ore, coal, you're underground, you're doing all kinds of things, can be simulated in one single platform to look at what your future looks like. And we do a lot of IoT stuff. So how do you measure energy? How do you collate or get information? And a lot of artificial intelligence, which is not the same as machine learning, where we have systems that are AI based, and we also have machine learning systems. We do a lot of process simulation and optimization. We have a lot of engineers in our business who are also heavily statistically focused. So we MNV is an area that we excel in, and hopefully do it very well. Some of the analytics that we're involved in is from the full ambit from transactional information, so just from metering, for example, descriptive analytics, what happened, diagnostics, which is a very, very complicated analytics area because it deals with causal analysis. Why did it happen? Predictive analytics is where MNV currently is. So MNV does a lot of predictive analytics, what will happen. It's all the counterfactual stuff. And then all the simulations, so the calibrated simulations and simulation tools are what we call prescriptive analytics. Is when you're planning, you can make changes to your process using a digital twin, and you could see what would happen. So ECS is involved critically in these areas. On this project, a quick overview is that the site was a cane sugar milling operation, fairly large. It was a retrofit isolation of steam boilers fired with coal and cane bagasse, that's waste biomass. And the energy savings measure, which I'm going to talk about at some length, is to improve the moisture removal from the bagasse as fuel, and thereby increasing the thermal efficiency of the steam generating process. And they had a very specific project to implement a 4-roll dewatering mill, quite an extensive project, quite risky because you're not sure whether, because you have to do the engineering before you, and the construction before you can actually do the verification. But they did it, and it was fairly successful. I'll go through that. Some of the interesting M&V aspects is that it's how to use engineering and thermo calculations to verify your regression models for adjusting baselines. And I think this is a very important part of M&V. Is it's not just a blind use of models, but really going back to the engineering and the scientific basis of MNV. We also, it's not often done, but in this project, we were able to use models for checking interactive effects. Often in MNV, there's a lot of discussion around interactive effects. Using almost like a whole sub MNV for checking interactive effects. There's also things like verification of change in production conditions or parameters. So it's not, you're not only verifying the key energy savings measure, you're not verifying the energy change, but you're also making sure that the key energy savings measure was actually working and did have change. And then in this one as well, it's very, very complicated measurement systems that you need. Work with laboratory data and so on to get the right information you need to do the MNV. Just a quick operations overview. It's a standard sugar mill. So you have cane coming in, you prepare it, you shred it, and then you have a pre-extraction mill. Then you go into a diffuser, you run along the diffuser. This all uses steam and hot water. And you then take all the juice out and you process all this juice in the rest of the process. The project that we're talking about is the dewatering molds at the end of this diffuser. How do you squeeze out the water out of the and also the juice out of the cane, and then you put your bagasse as thermal. And the boundary of this MNV was not this whole process, but really around the boilers. They have bagasse and coal coming in, and then you have these boilers, really large boilers, and then you have steam energy that's used to drive a steam turbine, and that steam turbine drives the dewatering mill. So this is a steam turbine that uses high pressure steam. And then once you've used the high pressure steam, you drop it down to medium pressure steam for the rest of the process, and so you go. So this is fairly large. It's a 450 ton per hour setup. It's 400 degree superheated steam at 32 bar gauge. And the energy in the fuel used per annum per season is about 1.3 million megawatt hours. So it's quite a lot of energy. And the energy in the steam is about 905 1,000 megawatt hours. So it's a lot of energy when you compare it to some of the processes that we look at. The project itself is the existing setup was that you drop cane into a mill. This is a 5-roller setup where you squeeze the cane. And the new configuration, the new construction was that you have a four-roll setup. There's a lot of engineering and design change to this to make it happen. You know, you're not just bolting on a simple a piece to the plant, but this is a major change to the operations. And basically, if you look at the roll itself, it's just got holes in it, it's perforated, the top roll, and this is in operation here, and the water, when you squeeze it, can actually go through these holes and out to the rest of the process. So it's quite a lot of engineering and setup to get this done and running. But what is the theory of this energy savings measure? So think of your kettle at home. You would bring in you have your water from your tap, which is probably somewhere around number 1 here. You then start to heat up this water to point 2, and the water starts to boil off. Normally in a kettle, you would stop somewhere over here where you won't have full 100% steam. And a kettle could never go beyond number 3. You can't get superheated. But what happens is in a boiler, the gas itself has got this water in it. It's got a lot of water in. 55% of the gas is water. When you put this fuel into the boiler, as the gas fuel into the boiler, what happens is you have to heat up this water before it'll evaporate during the combustion process. Now, this water vapor does transfer heat into the boiler, so you still get your heat back. But the problem is when it exits the flue gas, the stack, it's still containing an enormous amount of energy that goes into the atmosphere. So if you've ever gone past any operation where they've got wet fuel or biomass, you'll see that the boiler chimney looks like it's emitting a serious amount of smoke, but it's actually steam. It's the energy contained in the water that went into the operation at the beginning. So what you're trying to do is in the MMV process is to say, well, is there some theory behind why this intervention would work, and do we understand what that is? And this, just to give you an idea of what the losses are, the thermal losses because of the water in the boiler. So point 1 is the water in the fuel. So I'm looking at a pressure enthalpy diagram. The engineers in the on the other side there will understand this, but generally enthalpy is just the amount of heat that the water contains at various states. So this is at atmospheric pressure, and this is at 40 degrees C. It comes in, and then by the time you've burnt the gas and you've made the steam, you end up at number 4 here, which is around about 160 degrees, which you're coming out. So you can see the water going in has a heat content of about 170 kilojoules per kilogram. But when it exits the boiler at the stack, not as workable steam, but at stack, something that is unrecovered, it's 2,800 kilojoules per kilogram. Now, what this means is that every kilogram of water that you put into the boiler is taking away 2,500 kilojoules per kilogram of fuel energy. Now, the bagasse feed rate in this boiler is about 63 tons an hour. It's about 34.5 tons per hour of water. So at this point here, when the water is exiting the boiler as flue gas, it's really taking away about 24 megawatts of power. Now that's fairly large in anybody's terminology. So this has got a significant, the water content has got a significant impact on how much energy is going out the boiler and the thermal efficiency of the boiler. So if we look at the process, we in a typical MNV process, you would go to the baseline data. We've drawn the boundaries around the steam energy produced and the energy provided. This is coal and bagasse. And you build a regression model with its confidence intervals and prediction intervals. So it's a standard regression model that you would apply. Then you go along in your assessment period, and then you go and measure your actual energy that you've put into the boiler, and the versus the steam produced, and you then also have your adjusted baseline. So this red bit here is your expected value had you not made this dewatering ESM, energy savings measure. This is a standard way of doing it. However, in this project, we also will just go back to engineering principles, and we'll do a thermodynamic model check. So the boiler efficiency is known as, is calculated as the steam energy that you produced minus your boiler feed water energy. So you put heat into the boiler because you've provided hot water to the boiler at the beginning, so you have to take that away. And energy in over, energy out over energy in is what's called efficiency. So when you do these calculations of the baseline period, the efficiency was 48%, and in the reporting period it was 63%, giving a 15% improvement in efficiency. And when you go look back at the average saving over the using the regression model and the MNV methods, you get a 16% saving. So they're very closely related, and we're very pleased with this this result of being able to verify that the adjusted baseline process using regression models actually work out. Now, just a note is that regression models are unreasonably effective in MNV for counterfactual estimations. What I mean by unreasonably effective is that although it's a lot of work to get regression models out and baseline models and so on, the information they give you and the power that they have are unreasonably powerful in relation to how much effort it took to build those things. There is a statement that regression is not causation, and that's true. It isn't. However, regression is causation if you attend to bias and interactive effects. So, for example, if you wanted to get rid of bias, you would do a randomized control trial, and we do a lot of those in your experimental design or your M&D plan. You do a control group and a test group, and you have a whole methodology of removing bias. And if you use regression in those applications where you've been able to attend to bias and interactive effects, you end up with a regression model that is very, very powerful in determining causal relationships between activity and effect. So in this case, it was demonstrated that regression modeling is very, very powerful in giving MNV results. What you'd also do is, and you try and do this always, is if you have a main effect or a number of things that you know will influence the energy efficiency or energy avoidance, you go and check out whether this effect actually is true. So for example, in this case, the project was about reducing the moisture content. They were sitting at about 55%, and this is the little pink bit on the right here, and they reduced it down to about 52%. So the project worked, and we were able to verify that it works. So so in this instance, you have to be quite savvy with your ability to deal with statistics, and using advanced statistical methods allows you to verify your hypotheses, which says this project should be able to reduce the water content or moisture content of the gas, and the null hypothesis says no, that didn't change. And if you reject the null hypothesis, you say there was a change. So there is a change here, and was demonstrated. And also, there's times when you want to demonstrate equivalence, not only difference. So in this case, you said we're looking for a difference. And there are times when you want to look at equivalence. So if you want to compare 2 meters to each other, you wouldn't look for a difference in the meters. You would be trying to establish whether they are equivalent. That's a reversal of this test. So statistics works for M&V in these kinds of instances, even though it's not a requirement in SANS 50010 to do any of this, but it is helpful to verify the main effect. One of the important things about this project was that, as I explained earlier, there was a dewatering mill at the back end of the diffuser where you cook the cane. But that dewatering mill is driven by a steam turbine, and that so the question is the steam turbine using more energy now that it has to dewater more? So we needed to answer that question, because if you're going to use more energy, then you're extracting. It's a null sum game. So your project is not effective. So in a steam turbine, you basically generate the steam and get it out at 0.3 at the top here, and you drop it down through the steam turbine. We don't go all the way down to 4 in this case, because this process needed medium pressure steam, so the steam was taken off for other processes afterwards. Again, we used some engineering understanding. We know that the torque on a turbine, and power is torque times speed, that the torque on a turbine is related to the nozzle box pressure. That's the pressure of the steam inside the turbine before it drops through the blades and spins the turbine. So what we did is we were able to monitor the nozzle box pressure and cane processed, and we got another regression model for this sub process. And what we were able to do then is in the assessment period of the project, we were able to use this model to say the blue line here is the expected nozzle box pressure, and the red dots are the measured nozzle box pressure, which shows that on average the pressure was less, meaning that there was actually less power consumed and energy for dewatering. And it turns out that driving 4 rotors really assisted a lot with reducing the energy consumption and dewatering rather than the 5 rotors. And this kind of finding can actually be the possible scope for another 12-hour application because of the efficiency improvement of a 4 versus a 5 rotor setup. There's also another interactive effect that is quite significant. The fans themselves, so in a boiler you've got a forced draft fan and an induced draft fan, so the one pushes in and the other one pulls it out. On the induced draft fan, it's handling a lot of the mass of the flue gas, and if you have more water in the flue gas, its density is much bigger. So what happens is, if you look at the pressure of the system and the system curve, when you have more water in the flue gas because you had more water in the fuel of the gas, you end up with a higher power requirement to move the same volume. So for the same volume, you need more power in the fans. We didn't do any detailed work around this, but it could also be, this is another, because this is related to electrical power, not thermal power. So this could also be another thing that you could look at as a potential project where you just look at the fan power itself. The measurement system is fairly complex, and there's a lot of moving parts. So in the M&D plan, you had to really focus in on what could be sustainably measured over time, and how you use industry standards to get answers. For example, we don't measure real time the calorific value of the bagasse, but we do have sampling into laboratory for to get the values of all of these things. Balancing out how much coal you used. The coal is going to boilers on weightometers, so they mass measurements. The bagasse is known because of the fiber content and the water content of the bagasse. So the measurement system here presented a lot of technical issues, and it's not just a energy meter that you put onto a motor somewhere and got an answer. These kinds of projects can be fairly difficult to deal with in terms of designing first the measurement system and then managing that measurement system over long periods throughout the assessment period. 12 months, it takes some efforts. And then you have to do numerous calibration tests. I mean, tests upon tests to check that the weighbridge calibration, the laboratory instrument calibration, the weightometer calibration, the steam meter calibration, the temperature probe calibration. All these things have to be checked and sorted out. But it's worth it. This project, the incentive was sorry, just a look on here. The incentive itself was over 240 million rand, so it was worthwhile. Although the project itself was tens of millions to get in and highly risky, but there was a lot of benefit to this project to the client. That's my story, Carl. I'm ready for questions or
Thank you, Mark.
Okay.
Yes, we're moving to the panel discussions, and we'll deal with questions if there's any. I've not seen any questions posed on the chat room as yet. You're welcome to do so, but allow me to start off the session with some questions that I've got. I've got a question, at least one question for each of you, but let me start with the first presenter, who was Peter. Peter, you covered a few incentives. I presume there's many more incentives applicable to the energy industry that you've not touched on. Would you like to respond in that regard?
Yes, there are a number of incentives available. On energy efficiency, it's always been 12L. On renewables, it's now the CIP one. And then there's also other incentives that's aimed at infrastructure. There's one, the Black Industrial Scheme. Then there's also an agro-processing incentives that's available. And not all of them have an energy efficiency component, but if you spend some money on CapEx to implement some kind of a infrastructure project, then even if it's an energy project as well, you might qualify in some instances. In the manufacturing area, there's also AIS, another grant, and that one you can also use to get some grant money for solar projects, for instance. Yeah.
Thank you, Peter. On that, related to that, then, the 12L does not allow for double claiming as such, or double dipping, some refers to. If I use a project uses a incentive for capex like CIP or ADEP or whatever the case might be, would they be able to claim 12L, you think?
Yeah, they would be. 12L is allowance on the energy efficiency savings. So it's a different component that you claim on, and the other incentives focus on the capex that you spend on your project. So in most
Okay.
cases, there will not be double dipping. The only area where there could be double dipping is between carbon credits and 12L. So that's important to know.
Thank you, Peter. So this is an area where ESCO specifically could make use of huge opportunities in grant funding and incentives, tax incentives as well. So certainly an opportunity that can be explored by ESCOs and measurement and verification practitioners, because you could create work for ESCOs, which in turn creates work for you. So yeah, that's one way to look at it. Moving to Christo. Christo, you on the training side, you mentioned that the uncertainty in statistics is not being dealt with extensively or as elaborate as in the past. Please correct me if I'm wrong, but there was, even in South Africa, a general feeling that we overdoing these statistics and uncertainty reporting. And again, Mark in his last presentation showed exactly why it's important to also know these things and use these things. But from your perspective, what was the thinking behind that? And in very short space of time, can you perhaps explain what is covered?
Right. Yes. Thanks. Yes, we were all in agreement that in the previous training sessions there was a very large focus on statistics and an in-depth analysis into statistics. But eventually, when it comes to the body of knowledge in existence at that stage, and the exam and all that, it wasn't really covered as such. I would think there was something like 4 questions about stats in the whole question, 107 questions. We also all agreed that yes, statistics and uncertainty does have its place in the whole MNV process. Marcus explained that beautifully now. And Marcus had 1 or 2 mentions to that as well. But it becomes eventually a separate advanced course in how to apply statistics properly, correctly, where you need, especially in your more advanced systems, like, again, Mark has just shown us here. So we cover the basic statistics in the basic MNV applications, focusing on basics and fundamentals at this stage. So we're covering typical coefficient of the root mean square error, the regression analysis R squared and its downfalls and what it means, the mean bias error, and then confidence levels with confidence intervals. And what we then focus on as well is stated that there's no clear real line of what is accepted and what is not accepted. It becomes a negotiation between all stakeholders based on how much measurement can you afford, how much professional time and modeling and effort you can afford versus the value of using all those wonderful dark arts or statistics into the whole program. So we're explaining that balance absolutely clearly. So what we're focusing a lot on is what it all boils down to is eventually professional judgment in the whole counterfactual argument. And we get that across quite nicely, I think, at this stage.
Thank you, Christo. Which leads to the following question then is, what is the plans? You touched on this is you're covering the basics, and there's statistics is really advanced course. Is there a plan or intention to develop additional courses that might be more specialized or more focused in other areas?
Yes, we are planning to do so. Whether AEE is going to allow us, that's still part of the negotiation. We followed a totally different route here where we got experts in and actually paid them for their efforts and time, where in the past it was an absolutely voluntary system. And any voluntary system takes about 6 years to complete, and we were able to do this in 2.5 months. And this is the plan, but again, cost benefit applies to which we will go forward. And I think statistics, applied statistics, will definitely have a way in an advanced course in the close future. We just would like to get this sorted first and going, and then we'll take care of the rest.
Okay, now thank you for that, Kirsta. So you in a lot of money because you got paid in dollars. Is that what you're saying?
Not as
No,
much
that
as
was-
one would like.
that was just a joke. The next question really goes to Marcus, Dr. Marcus. Marcus, you touched on a project and you specifically mentioned that the project was energy neutral. When looking at doing measurement and verification on demand projects for demand, moving demand specifically to other periods, what's typical finding? Is there energy savings when this happens or not? Specifically considering that motors, if they run in a shorter space of time, you might get improvements in motor efficiencies. Your views on this?
Carl, yeah, and I think with a lot of the projects, we've seen unintentional energy efficiency. So the original aim of these projects was to not to have any inefficiency changes, because a typical irrigation setup, there's a certain amount of water that needs to be pumped for a certain type of crop. But what we have seen is that with these projects, normally the ESCOs also rolled out, they've changed actually the tariff structure from being a Ruraflex or a land rate tariff to a Ruraflex, which is time of use. And then suddenly farmers would say, okay, there is now a large benefit of also moving my load from these periods. But there was also energy efficiency also implicated. And that was one of the baseline anomalies we came across, because there was a definite demand reduction, energy efficiency also, although not at attention, because within the environment, the first line of assumption was that the energy efficiency, there would be no change because the same amount of water needed to be moved afterwards than beforehand.
Thank you, Marcus. So what you're saying is that, generally speaking, whenever you do a demand shift or load shift project, you should also specifically investigate the possibility of energy savings and therefore possible incentives in that regards. Is that what you're saying?
Indeed, you should be very careful, because there's with these projects we had a lot of cases where there was significant changes, and end of the day, with the service level alteration adjustment that was used, being a purely a energy neutral one, wasn't sufficient. We actually needed to change the approach to look at the operational hour energy neutral scenario, because most of the load was shifted and also a reduction in load due to the project interventions.
Thank you, Marcus. Then my last question is to Mark, Dr. Mark Rollins. Mark, let me start with the MMV question first. The work involved in the project that you presented is quite a lot of work and extensive measurements and metering, and there's areas that a normal individual might not be able to cover. Think about some of the graphs that you covered, things like that, which then increases the cost of measurement and verification. And you did touch on this, but I'm not sure as to the outcome, and you don't need to provide figures, numbers, perhaps percentages if you have them, but is there a cost benefit in doing exercises like this on plant from a measurement and verification point of view specifically?
Yeah, I think so. But I think the steps you're going to go through is in the project assessment, meaning that before you even started the project or you want to do an intervention, I think it's important to have the right tools and the right subject matter expertise around technology impacts and so on. So in this instance, because we are strong engineers, especially in thermal applications, smelters and boilers and all kinds of things that are hot, we are able to simulate process effect. So you're able to sit and say, if I do this thing, what will happen? And on that basis, you would then design your MNV, or we call it design of experiment, and you would then go and say, okay, how much effort do I have to put into this? And it turns out that on these large operations, it's definitely worthwhile measuring properly and getting it done. Even in this instance, we could have also claimed for all other things, like I said, the fans and the improved mechanical efficiency of the dewatering mill. So
Yeah.
Breaking up a bit.
of the MNV, so that we are able to say, well, what is it actually going to take, and we get commitment from the client. Although in this case, the actual MNV cost was less than 0.25% of the so it's fractions of a percent.
Yeah.
So it's like nothing compared to the whole scale. Even though it was a big project, and it took a lot of people to get it together. But I think the important thing is you need to spend time in understanding what the intervention is, what the expected size of the intervention will be, and basically the scale of it. There are many projects, for example, that we do an assessment upfront when we do the MNV plan, and it says, well, it looks like you've got a value of say 400,000 Rand here. Then we'd certainly want to trim it down as best we can to be more rough and ready to get the MNVs. We'd never spend this, the amount of time that we'd spend on a big project. We wouldn't reject it. We'd still want to look at it. But there are times when we simply, the risk is too high of actually even engaging in MNV, and we'll tell the client that it's it's not worth it. But it's very seldom that happens on our side.
I'm well aware you're very capable. Your company name says it all, energy combustion services. So it's really your field base. So certainly, are you, after the presentation that Peter gave, are you considering advising your client on the research and development and other types of incentives that they might be able to access?
Yes, this has also become the almost like a standard because of in the sugar. So we've run another 3 of these types of projects, and we're busy with one now at different levels. You know, it's not just the dewatering mills. It's like on the diffusers, on the evaporators. There's a whole bunch of things on the crystallization processes and so on. Yeah, so it's, there's the agricultural processing industry is a lot of work that they're doing to make themselves competitive. There's a lot of pressure on sustainability. So people are thinking really seriously about doing, not only just thinking, they're actually getting quite active in investments in carbon abatement and energy efficiency.
No, thank you for that, Mark. Then slightly off the topic question, you mentioned that artificial intelligence, AI, and machine learning is not the same. Perhaps you can briefly explain what the difference is, if you don't mind.
Yeah, look, machine learning is synonymous with saying statistics. So the old guys like you and me, when we used to practice our art, like say, I started on MNV type work, verification work in the late 80s, early 90s, and we got seriously involved with MNV work, not for incentives or Eskom, but for project verification. So we did a lot of simulation in those days, and we just called it stats. These days they call it machine learning. It just happens to have statistics these days is called machine learning, but it is essentially just statistics. What's changed though with machine learning is the wonderful array of tools. I mean, the tools now are just so powerful, but you need to know what you're dealing with, of course. So when I say, you know, you focus on statistics, you use quite advanced tools these days to do some serious heavy lifting that you could never be able to do before. So the difference with the machine learning process is it's more you're a subject matter expert yourself. You know math, you know stats, you know engineering, you know the scientific basis of things. You know how the world works, and you go and you try and model the world so you can get the counterfactuals. The thing that would have happened had you not done the project. So the counterfactual thing is what you're dealing with in machine learning. It's the predictive analytics. So what it would have been had I done the same work today as at the same efficiency today as last year, and you have this difference. That's what I call machine learning, is that the whole modeling and processing. AI itself it uses all the components of machine learning, but it departs from the subject matter expertise, in that it allows you for automation of things that will give you a lot more information without you having to deal with things. So I mean, automation is being things like you simplify things. So for example, we use AI to assist the machine learning process. But for me, AI is more like we have a tool. It's used on these large mining trucks. You've probably seen them. These huge, big these buildings on wheels. We've got a thing that looks at the road surface and other safety events and dust and all those kinds of things. And the machine itself does all the computation. It looks at the images, it infers the safety conditions, it looks at the road condition. It takes all kinds of things from IMUs, inertial measurement units, so how the truck is rocking and rolling and how it's vibrating, and how much dust is being kicked up and what holes they are and what your barriers look like and how far you are from other trucks and so on. For a human to put that together in real time, it's almost impossible. So you have what I call AI, so it's artificial intelligence. So we've embedded knowledge into the system so it can interact with the world without too much. But they are certainly different. You shouldn't be calling machine learning artificial intelligence, and vice versa.
Okay. Well, thank you for that.
We've got Dr. Carstens on the call. Yeah, he'll know a lot about this.
Yeah, he's a specialist in the field. Yeah. Well, thank you for that, Mark, and thank you for that lesson. Then let's move to closing remarks. I think let's close the day. Closing remarks. Peter, please start with the closing remark, if you don't mind, please.
Sure, thanks, Carl. Yeah, I think it was very informative. It was nice to see all the technical presentations as well. I think in closing, I would just recommend to M&V practitioners, ESCOs, clients, just be aware whenever you spend money, there might be some kind of incentive, and you're welcome to give us a ring and we can advise you.
Thank you for that, Peter. Thank you. Christo, last comment from your side?
Yeah. Yes, like with everything else, training is also evolving, and as well as the certification. We try to keep up, especially with things like we've seen from Mark and Peter's side. And then, of course, with the help like experts like Carl, you, Herman, and all other people, it becomes better and better and more involved, as well as applicable, where it can be properly defined and so forth. And then that old saying of yours, as always, ignore M&V at your own peril. You can miss a lot of stuff. It's your main risk mitigation tool in any energy management system.
Thank you for that, Chris. It's so true. Then Marcus, next, last comment from you.
Thank you, Carl. Yeah, I would like to add to Christo on that comment and to measure is to know. The moment you start measuring, and I've had a scenario on my house where we measured the soil water heat in all the conditions, And one day I went outside and I noticed, sure, there's a drip of water coming from the pressure valve. And I thought to myself, okay, is there any losses here? Because it seemed like a very small drip. But when I investigated the data, I saw that in a week's time, I've lost about 3,000 liters of water. Because during the night, when the pressure is higher, it's actually a little stream coming down. But you wouldn't have known it if you didn't measure. And with having measurements in place, you can start to apply MNV, and then you can actually look at real savings. So this is the exciting environment. And with that, and with closing remarks from Peter's side, Peter, I would just like to quickly drop a question on Section 11B. Isn't there much requirements to get 11B research funding or rebates? Should one submit with the research development patterns or aspects like that?
Peter, you're welcome to respond.
Yeah, I think 11D is quite a high hurdle for what research and development is. And currently, the DSI, Department for Science and Innovation, set out a white paper, and some of us in the industry has commented on it. So we want to make those red tape a little bit less, to make it a little bit more easier for companies to qualify for 11D.
Thank you, Peter. Yeah, but please take it offline, guys. You can discuss these things in more depth, perhaps personally. And then last but not least, Dr. Mark Rawlins, your last comments, please, Mark.
Yeah, Coral, I think that if we look at MNV as a professional practice, I think it's got a huge future. There's been a lot of backwards and forwards over the years of, is it valuable? Does it cost too much? But my current understanding through deep conversation with serious people in the world, people who run very, very big organizations, are that they're no longer just taking, oh, it's we think it's that. They're actually saying we want proper verification of our projects. I want to know exactly how much carbon I've reduced. I can't just go along and say, oh, because Mr. A said that it's 4%, we're going to project 4% going forward. We still see that today. We still see people saying that they ran a trial 5 years ago and the savings were 10%. And today the savings is still 10%, but they've doubled their production, whatever it is. So there's the market for a proper verification might not be under the formality of 12L or whatever, but it's definitely we getting a lot of work around saying that we can't just believe some section of the business estimation of what it is. We need proper auditing. We need proper verification of project performance and our performance. So for MNV, it's as a professional practice, I think it's a serious practice, and it's not just some bolt-on something that you do just only when you want to somehow convince somebody. It's becoming mainline. It might not be called MNV, but it is mainline. Big clients are asking for this extensively.
Oh, certainly. Thank you very much for that comment, Mark. And I think we're all experiencing this now. I don't see any other questions in the chat room, so let me close off. And before I do that, I need to thank the presenters first and foremost. Thank you very much. I know it takes time to present, to develop these presentations and to present and be part of these discussions, but it's extremely worthwhile. Both for, I think we can learn from each other, and we've seen this happening today, and we've got our audience who can learn from us and see what the importance of MNV is. And although we're actually a small group of people compared to the energy industry in South Africa, we do very important work, as you've rightly stated, Mark, and we need to thank you guys for all of that. The fact that we are MNV in South Africa, and Africa is considered the world best practice. And certainly we continue to contribute in this regards, and certainly what you've done today is part of that. Thank you very much. We really appreciate your participation and taking the time to do so. I then need to thank Mutlacho from the SAWEC for arranging and doing all the logistics around this webinar. Thank you for that, Mutlacho. Remember, the presentations is available. Just email him at events@saweconfed@org.za. Lastly, most importantly, is you all, the attendees. Without you, there wouldn't have been a need for a webinar. And certainly the amount of attendees which we've seen attended this webinar. And even up to this late point, which is slightly more than 2 hours already. Thank you very much for your attendance. Thank you for taking the time and the interest to participate and certainly learn from the presenters. We hope to see you at the next webinars and certainly be part of measurement and verification. Remember, as has been said often today, you will eventually have to engage with measurement and verification. So this is an opportunity to get to know some of those that is practicing and are involved. Being as a panelist or as a accredited MNB business or technical signatory or whatever the case might be. Thank you everybody for being here. Thank you for staying till the end up to now. And hope to see you all again in the next webinar. Thank you very much. All the best to everybody.
Cheers. Bye-bye.